Hello everyone, I'm your host MX2, and in this video we'll be going over the workflow for creating a dynamic grid that is able to retain its square attributes despite the amount of verts X and Y that you add, and then from there we will have that converted into a checkerboard pattern that we will then use as a mask, of course also protecting the edges. We'll use that as a mask to inset and delete those square faces, and then we'll use subdivision to convert it into a rounded result. After rounding it, we will use sine and cosine on the X for the position after separating it in order to deform this shape into a cylinder in which we will merge, and then from here we are just extruding it to make it solid, and then smooth and crease setup in order to allow it to be subdivided with the modifier outside of this. So if we jump over to this next modifier, we can see that we now have subdivision, and subdivision is able to hold because the edge crease is present, just ensuring that we only crease what we need to and we only subdivide what we need to. So from there, let's go ahead and jump in and begin. So here we are in Blender 4.3.0, and what we'll do is jump over to geometry nodes, and I'm just going to click on new and create a new graph. For this graph, we are just going to add a grid. And the first thing I did was control and then right click and drag to just cut my connection. And the first thing we'll do is we'll create a kind of dynamic grid, so that way all of our units are the right size every time. If we press Alt V in the viewport, we can look at the dimensions of the grid. So basically we want it to add more squares as we elongate it on the X and also on the Y according to an arbitrary scale that we set it to. This is probably one of the most minimal things we probably need to know how to do with geometry nodes, but to show how to do it, we're just going to take the vertices X and vertices Y and connect it, and then we'll come out to a math, and with our math we are going to subtract 1, and then we are going to multiply it, and multiplying it by 0.5 will do, and we can take that and connect it to the X. I'm going to grab both of these and we'll duplicate them, and we'll connect those to the Y. So now anytime I add more spans on the X or add more spans on the Y, everything will be good to go. In fact, I almost want to decrement the number by 1 just so this will say units Y1, but we can live with this. Continuing on, so now that we have our grid able to dynamically adjust and always be proportional to a square, let's also connect our scale. So in case we need to override it, we can just do that by grabbing this value, and that is connected to the multiply of both of these. So very basic. From here, what we want to do is grab a couple of masks, or I look at them as masks. So let's bring in an index, and I love the index. Let's also bring in a modulo, and so for our index we just want to up the value and then look at the faces, see if we can get it to be offset, but of course that requires a even number value, because odd will break and turn it into horizontal lines. But now we have our checkerboard pattern. The other thing is that I want to also mask the border, so that way we're basically not checkerboarding the border around it. So we'll create another mask. So for that, what I'll do is bring in a face neighbors, and we'll bring in a compare, and let's look at that, and we're just comparing. We probably want greater than, or maybe in our case we actually want less than. The difference is how it's going to behave when it comes to whether it's black or white. In our case we want it to be black because that means don't turn that area into a checkerboard, please. So now we have our two masks. Maybe we can plug them both up together. So I'm going to take this, and I just want to try a mix, even though it's not the best idea. Alright, just had to make sure, and we'll try with a math, and we'll do multiply, and now we have the result that we want. So basically this is our mask and this is our grid. So now let's bring this out and we'll connect this to an extrude. For our extrude, we'll uncheck individual and we'll plug up our mask that we created. We'll turn off offset to 0, so that way this does nothing, and we'll bring out a scale elements. And now with this, we can actually begin scaling these values. Also, we want to check individual. It appears that we made a mistake there. And we don't even need to see the mask. We just need to see what we're messing with. But you see that now we have a padding around the border, and we also now have our checkerboard pattern in the middle. So let us go ahead and choose delete. We want to delete geometry, and we want to delete faces, and we want to delete the faces that we are basically extruding inward. So let us bring a group input, and for our group input we'll connect our scale. So if we look at our end panel, we can adjust the naming of these. I hate that this is always the smallest one. We'll call that global scale. We'll call this whole scale. So now we have the scale of the whole that we can adjust, and we have the global scale that we can adjust. In fact, I've been naming everything lowercase lately. I've just been in a lowercase mood. Alright, so now that we have all of that set, what we want to do is subdivide it. Let's subdivide it. Sorry, I don't want to get ahead of myself with the surprise ending. Alright, and now that we subdivide it, it is all a circle. In fact, if we give it 2, we see that they are very rounded. In fact, we turn off overlays, we have basically created a hard surface band-aid. Alright, so we are making progress. In fact, that last level of subdivision, we won't even handle through this. What we'll do is go ahead and make it solid, and for me, making it solid is extrude. So we'll extrude the mesh. I accidentally tried to use a mesh operation in the node editor just now, causing an error. I have to make sure that doesn't happen. Let us join, and what we'll do is join the original mesh, and what we'll do is merge. And now that we have merged, this geometry is now solid, manifold, and thick, and we can just adjust our extrusion amount here. So let us bring in another group input, and we'll just call this extrude scale. So now we have an extrude amount, we have our holes that we can adjust, and this whole thing is dynamic, best of all, so we can get in here and make it as long or as short as we need to be. And we see that on certain numbers the checkerboarding gets offset, but that's fine. I'll have to be thinking about that now, and I'll come back with another video about how to permanently always checkerboard. But anyways, continuing on. In fact, I'm pretty sure if we just took it, did some math along the Y to offset it, that would do it. Alright, so continuing on. Now what we want to do is deform this thing. So I'm going to bring in a set position, and for our position we are going to use a combine XYZ, and then we'll use a separate XYZ, and we'll go to the position. And the more I do this, the more I realize that Blender needs a way to allow you to work all the way back to the position, breaking it out into this from here. It's just strange to do this over and over all day. So let's use a sine. And sine is something I've experimented and dabbled with in the past, but now I think I really get it. And that's because it's really basic, not because I'm smart, just because I get it. So we'll use a sine for the X, and then we'll plug that to the X. We'll use a cosine for the X, we'll plug it into the Y. We'll plug the Y into the Z, and this is our result. So from here, this is where the tutorial begins to get more interesting. So we'll bring up a vector math. We'll rip it off by holding Alt and dragging it to break its connection. We'll change it to scale, and then connect it. And now we have a global scale that will allow us to make these connect as much as we need them to. So with this, let's bring in another input, group input, and we want to adjust our scale. In fact, we probably only need one scale. I don't even know if I like the name position scale, but it certainly works for this. In previous iterations of this exercise, I would have brought in a curve and then deformed it around a curve using Blender modifiers like the classical way. But I'm obsessed with being able to do everything inside of geometry nodes so I can build more and more complex kits without having to go out and use things like simple deform, twist, and other classic operators. But this to me represents a victory. So let us go ahead and make this connection, and just like that we have created a rounded, checkerboarded, hold, dynamic piece that we're able to adjust the count of if we need it to be bigger, if we want it to meet up. So let's grab the pos scale and we'll scale it up to maybe something like that. And let's also mute subdivision for a moment. I'm going to rip it out at this part, and we're going to reinsert it later after we've made it merge. And this is something I'll probably come back and revisit in future videos, but to have it join up enough to automatically merge, to me, would hit the spot, because then we have basically twist 360 happening in node form, which is great because my experiments with these have been to just see how I can model the things I would normally model, but inside of geometry nodes. So now we look at this, we see that we have our intended result, and we're able to dynamically adjust it. Very nice. In fact, we lost a bit of our thickness here, and we lost our thickness because of the order in which we performed these operations. So here we performed a deformation that turns it into a 360 object. What I'm going to do is bypass that and then just cut that connection. And what we'll need to do is select that, press Ctrl H so it's smaller, but we'll grab all these nodes and we'll just bring them back one, because it's all about order of operations. So just like you would with modifiers, you also would with nodes. So let us make the connection, and now we are looking at this. So far so good. In fact, we can bring our merge by distance directly after this, and then we look at what we have here when it comes to extruding it, and then we have our subdivision, which our subdivision for some reason did not work out. Now, why did it not work out? Well, this is where you want to put your diagnostics hat on, because if we go into face orientation, we could see that the second face just did not get its normals flipped, because its normals aren't going to be flipped like that. So let's do a flip faces, and now we have it behaving the way it's supposed to. So the other thing is, what if we wanted the holes to have a better reaction with subdivision, because right now they are getting a bit of abuse. In fact, I'm looking at this thinking how I handled this previously compared to now, and how we might want to approach it that way now. So what I want to do is make it rounded, so we have our grid, and then we are deleting it, turning it, and setting it. In fact, we can label everything as well. So let's select all these, Control J, F2. So we'll just call that dynamic grid. We'll call this boundary checkerboard. Alright, someone got renamed. F2. Alright, and that'll be our boundary checkerboard. This will be our deform to cylinder. So do something like that, and then we'll label this one checkerboard inset. So we have our grid, we have our inset, and then we are deforming it to a cylinder. Alright, and then from here we are doing a merge, and then we are rejoining it up, then subdividing it. So this one is extrude face, that's all it is. And then we are looking at subdivision at the very end of our stack. So if we pull back, we didn't do a ton of work. All we did was just go in here and make this able to come out the way that we wanted it to. But we can also still do more. In fact, I'm just looking at this thinking about it. So if we do our checkerboard inset and then we perform subdivision. So I'm alt ripping this out and we're just experimenting with different phases of it being in the stack. So here we are with it here, and what we want to do is probably keep our corners. So we want to keep our corners, and that way subdivision can live here. So now if we go down to this side, we see that now everything meets up, everything's rounded. And then when we go here, we see that everything is rounded once again. But let us subdivide it from the outside. So I'm just going to select this and press Control 3 just to put a subdivision on it, and we see that this is what we're dealing with. We want this to always be up no matter what mod we select. So now I can just select the subdivision mod, and you see my graph doesn't disappear anymore because I checked the check, or checked the pin, sorry. And now let us do the final part. So what I want is for this to be set smooth. In fact, we can lower the resolution just so we can really see what we have going on here. And let's just turn off visibility, and that actually can work for the object. You know, it'll look good, it'll work good, but let's say we wanted crispy, sharp tops. So we have our face smoothing, now we need our edge smoothing. So what we want to do is for selection, we want to do compare and do greater than, soon probably to be less than, and we want to change this to be float. We want to do it before we connect this, because once you change it, it'll disappear. And let's change it to less than. Alright, and just a little bit of smooth experimentation here between greater than and less than. Now if we wanted to get rid of all the guesswork, we can jump in here on the viewer and we'll enable it for edge, and let us turn on attribute text. So now we're looking at false, 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 and we just want it to be true on the edges. So I believe we got our intended result. And it's almost there. So now we got it smooth on the outside, but we still have a little bit of faceting on the inside, meaning we need to get our angle just right. Instead of playing with the I believe radians, we could also change this to degrees, and once it's degrees we can put in an actual number like something like 30 or 60, or is it 2 radians? My mistake, 2 radians, 60 degrees, 2 radians. And now we can put in something like 30, maybe raise it up to I don't know, 45. We'll raise it to 60 just to ensure that we have only these edges being marked sharp, and along the top edges anything lower we see it begins to clip those because we would need basically more smoothing in our subdivision to grab it. But continuing on, the next thing also is that we want it to hold for the subdivision well. So let's take a look at that. Alright, and this is what we're getting right now. So let us bring in a store named attribute. I had to click it a couple times because I know that it's showing me a improper view, but I wasn't sure if it was being shown on screen. So we'll call this crease edge. And you know it's right because every edge is now creased to 1, so we need to also give it a mask. Previously we had this mask going over here that looked pretty good, but I don't think that mask will work for this one. But let's give it a try. We'll plug it in the selection and we see that it is doing the opposite. So let's try not. And if we mute it, we see that it goes back to being rounded. And if we unmute it, we see that we now get a nice sharp result on the inside. So let's press Alt V and not wireframe. Let's turn on overlays and look at our result. So now we have a very nice checkerboarded cylinder with 2 connections in the back, just to kind of offset it to protect the edges. Of course, if we wanted to get rid of that altogether, we can also put that on a checkbox. Let's grab these and we'll just name them crease. Ooh, that is not how you spell crease. Crease and sharp. Alright, so we now have our crease and sharp. And we are making great progress. We are progressing right towards the end. And what if we did not want a checkerboard? I mean, what if we did not want this to meet like so, with a border protecting the perimeter? We could always have that toggled off. I'm looking at it just thinking about the likelihood of me wanting it toggled off, but let's see if we can also get this to meet up in a more suitable way. Alright. We'll bring it to there, and let's look at it via subdivision, and we see that we are keeping that corner, but we're not keeping that corner. So it looks like that's why I was originally offsetting it from the edge, is because if we have it all the way on the edge, the subdivision will take it. So in the next iteration, I'll have to figure out a way around that, so that way we can have a perfect checkerboard hole. So let's pull back and look at our final result. And so we basically have this checkerboard cylinder that's able to dynamically have its holes adjusted. And really we didn't go through too much difficulty with it. So let's also set a material. And the only material present is material. Dot stroke belongs to grease pencils, so we won't talk about that.